So in the parallelogram ABCD, L and M are the midpoints of the side BC and DC respectively. Express the lengths AL and AM in terms of AB and AD. Furthermore, prove that AL vector plus AM vector equals to 3 over 2 times the vector AC. Okay, let us begin. First, we'll try to understand the problem graphically. So we begin by considering a parallelogram with vertices A, B, C, and D. So here, L is the midpoint of the side BC and M is the midpoint of the side DC. So we join AL, AM as well as the diagonal AC of the parallelogram. So first what we'll do, we'll need to express the length AL and AM in terms of the sides AB and AD of the parallelogram. And once we are done with that, we also have to show that AL vector added to AM vector, that's equals to 3 over 2 times the vector AC. Okay, so first what we'll do, we'll consider AB vector and AD vector, and we will suppose that A corresponds to the origin. Then we have B, let's say B corresponds to the vector A. So this is the position vector of the vertex B with respect to the origin A, and D vector corresponds to the vector B. That means this is the B vector is the position vector of D. So here let A be the origin. We have the origin, and OB vector corresponds to the vector A, and OD vector. OD here is actually AD, so we have AD vector corresponding to the vector B. Now, we will consider the triangle ABC. Now, in this triangle ABC, what is AC vector? So, AC vector is going to be equals to AB vector added to BC vector. This is from the triangle law of vector addition. The AC vector is going to be equals to AB vector plus BC vector, but in place of BC vector, we can use AD vector as well. That's because it's ABCD is a parallelogram. So here we have considered BC vector to be equals to AD vector. Now AB vector, that's vector A, and AD vector, that's vector B. So we now have the position vector of point C. So that's going to be A vector plus B vector. Fine. Now we come to the point L. So L is bisecting BC because it's the midpoint, or in other words, we can say that L divides BC in the ratio 1:1 internally. So using the internal section formula, the position vector of the midpoint L is going to be 1 times the vector AB added to 1 times the vector AC. AC divided by 1 plus 1. Now AB vector, that's the vector A added to AC vector. AC vector is A vector plus B vector, whole divided by 2. So this will be equals to 2 times A vector plus B vector divided by 2. So now we have AL vector. So AL vector will be equals to 2A vector plus B vector, whole divided by 2. This is also equals to, now what is A vector? We can replace A vector with AB vector. So we have 2 times AB vector added to B vector. So B vector is simply AD vector, whole divided by 2. So all we have done is express the vector AL in terms of AB and AD. These are the two sides of the parallelogram. They are the two adjacent sides. And we're going to label this as number 1. Now similarly, we can also find out the position vector of the other point M. So we get AM vector that will now become equals to A vector plus 2B vector, whole divided by 2. Or we have AB vector plus 2 times AD vector, whole divided by 2. So let this be number 2. So we've expressed AM vector in terms of the adjacent sides of the parallelogram AB as well as AD. Now what we'll do, we're going to add these two vectors. So adding 1 with 2. So that's going to give us AL vector plus AM vector, that will be equals to, so we're going to add these two. So we have 2A vector added to A vector, that gives us 3A vector added to, so 2B vector plus B vector will be 3B vector, whole divided by 2. So we have 3 over 2 multiplied to A vector plus B vector. But we have already defined that A vector plus B vector, that is the position vector of point C. So it thus can be replaced with AC vector. So we have successfully showed that AL vector added to AM vector. So this will be equal to 3 over 2 times the vector AC. So we have successfully proved the problem.